In this section, we're going to talk about, we're going to derive three equations. We'll derive the equation for time of flight, the total time for which the projectile is in the air. We're going to derive the expression for the maximum height it reaches, and we're going to find out what's the horizontal range. Here it is. So our projectile motion, so my x and y axis, x and y, and again we will consider that the object is thrown with some velocity v0, and that initial velocity makes an angle alpha with the x-axis, and we can decompose that vector. The component along the horizontal, always the component along alpha, always cos alpha, and the one opposite to alpha, sine alpha. And I'm going to point 3 points. I'm going to plot 3 points on this graph. I'll call this as 0. This highest point where it reaches, I'll call it as A, and this point B. When it reaches the highest point, we know its y direction velocity is going to be 0. Its x direction velocity remains the same. Remember, in the x direction it's going in a uniform motion. It's only in the y direction we have acceleration due to gravity. So the first thing I want to calculate is the time of flight. To do that, I'm going to consider the motion from 0 to A. So this is to calculate time of flight. So if I know how much time it takes to go from 0 to A, then if I just double that time, I will know how much time it takes to go from 0 to B. So that's what I'm going to do. And therefore, I'm going to consider the y-axis. What are the things that we know? I know that the initial velocity is v0 sine alpha. I know the acceleration due to gravity is minus g. Final velocity, which is at A, along the y-axis, it's 0. So which equation can I go for? Well, v equals u plus at. So 0 equals v0 sine alpha minus g into t, and therefore t becomes v0 sine alpha from g divided by g. And remember, this t is to go from 0 to A. That means to go from 0 to B, which is the time of flight, is going to be 2 times this value, and so I have my first equation divided by g. So this is the expression for time of flight. Alright, next I want to evaluate this height, maximum height it reaches. And again, it's obvious I have to go for y-axis. So again, I'm going to do the motion from O to A, and I'm going to consider y-axis. Since I know the time, I can use any equation. I would like to go for, let's see, what are the things that I know? I know the initial velocity, v0 sine alpha. I know the final velocity, v. Again, sorry, it's not v, it's 0. Final velocity is 0. And I know the acceleration due to gravity. Which equation can I go for? I can go for v square equals u square plus 2as. Of course, I could have gone for s equals ut plus half at square and substituted this time, but this is easier. So let's go for this one. So 0 equals v0 square sine square alpha minus 2g, and our s is nothing but our h here. So you shift over here, so 2gh equals v0 square sine square alpha, and h becomes v0 square sine square alpha divided by 2g. There. So that's the expression for the maximum height. And finally, I want to calculate the range. This distance is the range. So it's obvious I have to consider the motion from O to B, and it will be along x-axis. What are the things that we know? I know the velocity is v0 cos alpha. I don't call that as the initial velocity. It's the velocity because it's not going to change, uniform motion. There is no acceleration. I know the range, the displacement is the range. and I know the time. The time it takes is the time of flight. And so the equation which we are going to use is S equals ut, and S is nothing but the range. U is my initial velocity, which is v0 cos alpha, and the time is this time over here, this one. So I'm going to substitute that as 2v0 sine alpha divided by g. I will continue this side. I have a v0 square, r equals v0 square, and then I have this 2 sine alpha cos alpha. Let me show you that. Oops. Okay. Here is a 2, here is a sine alpha, here is a cos alpha. A 2 sine alpha cos alpha can always be written as sine 2 alpha. That's a trigonometric identity. So I'm going to substitute that back. So that becomes sine 2 alpha divided by g. That becomes the expression for range. There we have it, 3 equations for the projectile motion.